The precise location of the ITCZ determines the location and intensity of seasonal patterns of wind circulation known as monsoons.
The monsoon climates of the world exist in Africa, Asia, Northern Australia, and to some extent in the Americas. They also include about 65% of the population of the world. And there's a good reason for that, because associated with the monsoons are very wet summers, warm summers, lots of rainfall, and generally very, very good agriculture.
When the monsoon fails, it's bad. Now, why would it fail? Well, not everybody knows exactly why it fails, except we know that if the ocean temperature is warmer than normal, it takes longer for the monsoon to set in. Or if the land is cooler than normal, it takes longer for the monsoon to set in, and sometimes it fails entirely. We do have a monsoon in other locations. For example, we have a monsoon in North America, where we have air moving from the Gulf of Mexico into the central United States every August, and you get a lot of severe thunderstorms, a lot of rainfall, even here in Colorado, comes from what we call the American monsoon.
So what you find within a monsoon season, which lasts, say, from over India, for example, from June all the way through September, are periods of where you get very large amounts of precipitation for 2 or 3 weeks, and then mini droughts for 2 or 3 weeks, and large amounts of precipitation once again. Within those periods of very large precipitation are storms which are moving through.
Storms can range from a tropical cyclone on the order of Hurricane Mitch to an extratropical winter storm, like a blizzard or major rainstorm. Often, a storm begins as a result of air masses that have collided.
We have many different kinds of storms. You can have rainstorms, you can have snowstorms, you can have dust storms, you can have tornadoes, thunderstorms. And the thing that determines this is I think, the temperature and the winds. When you have cold temperatures, you get snow. When you get warmer temperatures, you get rain. In the United States, most of our precipitation begins as snow, as ice, but it melts and becomes rain as it falls into the warmer air near the surface. In the tropics, you can go through a different process of forming rain, and it can be water the whole time.
And there are reasons that are not very well understood why certain storms are stronger than others. The sea surface temperature tends to be warmer, perhaps. In the upper troposphere, 10, 15 kilometers high, the circulation is such as to be more conducive to the formation of strong updrafts rather than tending to slow them down. And so there are many reasons. Precisely, if one were to say 6 days in advance, will this be a strong hurricane or a weak hurricane, it's difficult to know. But just sometimes there's a confluence of influences which are such as to allow a storm to grow. For example, generally the storms in the northwest Pacific Ocean, the typhoons, sometimes become what are called super typhoons, and they seem to be stronger there than, say, in the Atlantic. I think the issue with Mitch is that things were right for its formation, and things were wrong in terms of where it finished up.